Assalamualaikum and a very good day to my fellow panels and to everyone who is watching this video. My name is Muhammad Nazri bin Muhammad Salme and I am from Faculty of Mechanical Engineering, UiTM Shah. Today I'm going to present about my final year project proposal entitled Vibration Suppression of Flexible Manipulator System based on Bacterial Foraging Optimization. For your information, my final year project is supervised by Dr. Muhammad Sukri bin Hadi. So the outline of this presentation is that I have project background, problem statement, objective of study, scope of study, literature review, research methodology, expected results, and lastly project planning. As a briefing, first of all, this project is all about to develop an accurate modeling of a flexible manipulator system and to apply a vibration control to the system because it is the flexible manipulator system is seen to be a huge potential to replace the rigid manipulator system in the industry. As we can see, the rigid manipulator system is made up of heavy and bulky structure. It has low operating speeds and low efficiency. Even it is offering good tensile strength and has less deep deflection. So, in the other hand, what can flexible manipulator system offers to the industry? Basically, flexible manipulator system is made up of flexible structures of lightweight steels made of links and joints and the flexible manipulator system can provide high operating speed to the industry, has better efficiency and also more mobility and less implementation costs. But the flexible manipulator system has unwanted vibrations that has delayed its potential to be implemented in the industry. Moving on to the problem statement, the first problem that we can see is that rigid manipulator is heavy, bulky, and not efficient. In the other hand, flexible manipulator is lightweight, but it experiences unwanted vibrations. The vibrations that flexible manipulator system experience is low in its frequency, but the vibration significantly can reduce system performance and might also cause system malfunction. And the vibration may cause hazards to human and become discomfort for human to use. As we can see in the picture, these are some harmful accidents that happen caused by flexible, not flexible, rigid manipulator system failure. We have Mr. Zhao who was jabbed by 10-inch steel spikes and has Miss Holbrook that was hit by a huge robot arm in a car factory. And this is the reasons why we need to consider more implementations of flexible manipulator system. Alongside, we have to retain more energy efficiency in the industry. Moving on, we have two objectives of this study and it is mainly parted to two scope which is modeling and vibration control. The first objective study is to represent in model a flexible manipulator system by using system identification technique modeling approach based on bacterial foraging optimization and evaluate its efficiency with a recursive least square algorithm. And the second objective is to design a PID controller tuned to achieve vibration cancellation at the endpoint, acceleration of the flexible monitoring system, and also to achieve accurate hub angle positioning of the manipulator system. Next, in this research, there are 5 scope of study covering 2 research objectives: modeling and vibration control. In modeling objective, the first scope study is to develop a modeling for a flexible manipulator system by SI technique based on swarm intelligence algorithm implementing linear autoregressive with exogenous model structure and deploying bacterial foraging optimization. Before we will be verifying its performance with recursive list algorithm. Then the models will be evaluated with 3 factors: lowest mean square error, correlation test within 95%, and also good stability of pole zero diagram. And the best model will be selected by single objective function, which is lowest mean square error. After that, the fourth scope of study is we have we will develop active vibration control based on PID controller that is tuned heuristically to suppress vibration of the flexible manipulator system at the endpoint acceleration and to achieve accurate hub angle positioning. And lastly, the last scope of study is to verify the PID controller by introducing 2 forms of sinusoidal disturbances or multiple forms of sinusoidal disturbances to the PID controller. Literature reviews has been conducted in this research focusing on 3 major fields, which is modeling, swarm intelligence algorithm, and lastly vibration control. So in the first focus, modeling, based on the literature reviews, I found out that we have finite element methods. We have many kinds such as finite difference method and partial differential equations, and I choose to use system identification technique because this is a technique that is most suitable to implement swarm intelligence algorithm. So basically, the SI technique is a mathematical expression of a real system based on input-output data of a real system or parameters of the real system. Um, the implementation of SI technique will be needing a mode shape, and there are many mode shapes such as ARX, RMAX, and ARMA. And I choose ARX, auto-recursive with exogenous mode shape, because of its simplicity and effective. Next, jumping on to the next focus in the literature review, we have swarm intelligence algorithm. So basically, swarm intelligence algorithm is an artificial intelligence of a group or agents that has special features in solving problems. There are many examples of swarm intelligence algorithm such as ant colony optimization, bird mating optimization, genetic algorithm, bats algorithm. There are so much, and I am encouraged to implement bacterial foraging optimization because based on the literature reviews, bacterial foraging optimization has good optimizing and has good problem solving capabilities. Literature reviews are then focused on vibration control field. So basically, there are 3 kind of vibration control. first is passive vibration control, the next is semi-active vibration control, and then active vibration control. And based on my literature review, I can conclude that active vibration control is the most suitable control regime for the flexible manipulator system, because the flexible manipulator system experience low vibration frequency, and based on the past researches, they have proven that active vibration control is the most suitable to control the low vibration frequency of a system. And then I will be implementing PID controller method to cancel out the vibration at the endpoint and to achieve half angle positioning. Many researchers also concluded that PID controller is a good method because it has less complexity and good effectiveness. Basically, MATLAB 2019A will be the platform for the PID controller method. Moving on, I will be explaining about the research methodology that will be conducted in this study. So basically, there will be two research objectives, which is modeling and vibration control. Before starting the first research objective, I will be conducting literature reviews to gather informations from the achievements of past researchers and the methods that they are using to complete their study. And after the literature review, I will be conducting a modeling of a flexible manipulator system based on SI technique, deploying bacterial foraging optimization and recursive least square algorithm. The process will be repetitive until the model has low mean square error, good correlation test within 95%, and excellent stability of Poisson diagram. And the next is the bacterial foraging optimization models will be selected the best based on one single objective function that is lowest mean square error. After the best bacterial foraging optimization models achieved, the model will be implemented in the PID controller in the next research objective. So a PID controller will be developed to attenuate vibration of the flexible manipulator system of the endpoint acceleration and to achieve the accurate half angle positioning. So the PID controller will be validated and then by cooperative studies, and then performance analysis will be conducted to make sure the vibration suppression of the flexible manipulator system can be reached into its maximum level before the research end. By the end of this project, I will be expecting 4 expected results. The first result is that I acquired approximate models of flexible manipulator system based on recursive least square algorithm and bacterial foraging optimization. The model that I obtained are validated based on 3 criteria, which is lowest mean square error, correlation test within 95%, and good Poisson diagram stability. And then the results show that bacterial foraging optimization has better modeling because better modeling than the recursive least square algorithm, because of the swarm intelligence algorithm has special features to solving problems and optimizing. And the last result is that I successfully developed a PID controller for the best model and the controller able to attenuate vibration at the endpoint acceleration and achieve up angle positioning with good and quick cycle time. For the project planning, the activities in this project has been well planned alongside with its time frame, and so far I managed to catch up with the time frame, and I am on the right path right now. As for the remaining period, the remaining activities has also been well planned alongside with a good and reasonable time frame that has boosted my confidence to end this project within the period given. So that is all about my proposal for my final year project. I am very thankful for your time and attention to my video. If any inquiries, please do not hesitate to contact me based on the details that I have given. And thank you so much.